negative 1. Right? There are rare cases where they're equal, but if they're equal, they're going to be called congruent, not similar. Okay, so there's a difference. All right, so the first bit of this, before I let you guys do some problems, would be going back through what ratio is, what proportion is, how to solve them, that kind of thing. All right, so you guys remember what a ratio is? What?
Like 2 to 1 or something.
It's what?
Like 2 to 1. 2 and then the 2 things and then the 3.
Yeah, you can do that. It's just a comparison of two numbers. I have a lot of stuff up there. Obviously, you shouldn't write everything. So, you should begin to pour in, you're taking these notes and you're condensing it down anyway. But a ratio is simply you take two things and compare. Like you said, you can put the little colon in between it, 2 dots. That's one way to write it. Most of the times, you guys, I'd expect you're going to write it as a fraction. Okay. Generally, it's easier to write things out as a fraction. So for the first part, where you're basically practicing doing the ratios, guys, just understand. If I ask you to write a ratio of 2 numbers, make sure it's fully reduced. Just like it has up there as an example. If I give you 8 to 12, now I want you to write that as a ratio. I want you to reduce it down to 2 to 3. One thing you have to make sure you're doing, because the first part is simply going to be, here's a ratio, simplify it or reduce it. You have to make sure that your units are the same. Okay, so you are going to have to do some kind of conversion between units. Like you might have inches and feet together. But you might have like quarts to gallons, pounds to ounces, maybe some metric stuff, meters to kilometers, that kind of thing. When you guys are doing conversions, in general, it's easier for people to convert something to smaller units than it is to convert to bigger. Like if I had something like give me a number.
5.
5. So if we do like 5 inches over like 2 feet. And I said, okay, I want you to go ahead and reduce that or make it a fully simplified ratio. I wouldn't expect anyone, like I need the top and bottom to be the same units. Like I can't have inches and feet there. I wouldn't really expect anyone to convert inches to feet. Okay, because usually it's harder to switch to the bigger unit. And the reason is, if you switch to the larger unit, you're talking about dividing it. Like there's 12 inches in a foot, so if I did 5 inches down to feet, it would be 5 over 12. So I'd have a fraction. But if you switch to the smaller one, you're always going to be multiplying. So if I took that 2 feet and changed it to inches, it would simply be 24. All right? And then the last thing would be, so if I gave you that and I said simplify, I would expect this step to happen, and then I would expect it to be written that way. Okay? You don't use the units disappear, they kind of divide out. If they're the same top and bottom, you can just cross them off. It's just how conversions work. Alright, so just make sure that if you do conversions, guys, convert to the smaller units. And most of the conversions will be things that you are familiar with, hopefully. If not, like if you get to one and you don't know what it is, just ask. I'll tell you what the conversions are. And if I do something like that on the test, it'll be common. I won't like throw some random thing on there you barely ever use. You don't have to convert it. Alright, so next thing. Okay, so next thing, building up would be the proportion. You guys know what proportion is? If I said write a proportion out, could you? Yes or no?
Yes.
You could? What does it look like? Come on, you said yeah.
5 over 10 is 210.
What? Just proportions just as one fraction equals another. It's like so. It's basically you take two ratios, you set them equal to each other. So in essence, what you're doing with proportions, guys, is going to be solving equations with them. So like proportional equation. These are the things where you'll have like, 5 over x equals like 6 over 20 or something like that. And it'll say like solve for x. Which, again, like I said, should be 3 algebra kind of stuff. All right, so it should be just like this part of it is just kind of remind you of that, because you need to be able to kind of be reminded of this before we get into the similarity. The similarity revolves around you being able to work with ratios. All right, so a basic proportion would look like that one. I'm probably not going to test you on the idea that a proportion is made up of means and extremes. I bring this up because a little bit into this chapter, we're going to run into something called a geometric mean, and the geometric mean is set up revolving around this kind of proportion, understanding that the means are the numbers that are directly across from each other in these positions where the C and B are. And the geometric mean actually revolves around that word right there when we get there. Okay, so this will come up in that manner, but I'm not going to like write out a proportion. I'm going to say, what are the extremes of this proportion, or what are the means of it? All right, just be familiar with it. It'd be a good idea to write it out, just to reference back to it, but it's not like a, make or break kind of thing in terms of the test. All right, now, for working with the equations, there's going to be certain properties that you guys have to be reminded of here. I think I have 3 or 4 that I actually have, but I think I cut one out. There's normally 4, but I don't remember if I left all 4 up there or not. So your properties, guys, the first one is the one you use to solve this, cross product. Right? That's just a matter of, this is the one you guys would just call, your cross multiply. This is the thing you do, like I said, to solve the equation. So wherever that x is, you cross multiply, you set it equal. And once you do the cross multiplying, you come up with a basic, should be a linear equation. All right, where you're doing like probably 1 or 2 more steps to it. Should be too many more steps once you do the cross multiplying part. If you multiply correctly. Okay, so first one's that. Next one is reciprocal property. This one is just like a manipulation kind of thing. It's saying that, if I've got a proportion and I just take it, the entire thing, and I flip it, it doesn't change the value of the proportion. It's still the exact same problem, and you still go about solving it the correct way. Usually with the whole reciprocal stuff, this might be something that a person uses if they don't like to see variables in denominators, or maybe if I had to get the units in the direct manner, I would flip it. If I was talking about the speed of something, speed usually like feet per second, meters per second, that kind of thing, miles per hour. If you never realize, guys, when they say miles per hour, the per is like the division thing. So I know miles goes on top, hours goes on the bottom. So if I had that reversed, this property allows you, like if I had hours on top and miles on the bottom and I wanted to talk about speed, I would simply flip it. Okay, and this is the property that would allow you to do that. Right? But otherwise, in terms of solving out proportions, it doesn't really have that big of a deal on it. The next one, this one right here, there's no names for this one or the one after it, because these two are simply manipulations. I'll put them both up there so you can write them out. But this one right here might be the only other one that I can see people using a lot in terms of solving it. If you look at it, all that's happening is they're saying if you start with this proportion, you go here, it allows you to flip-flop things diagonally. Like if I just interchange the things that are in the positions diagonal with each other, it doesn't change the value of it. Okay, and I'm not talking about multiply, I'm talking about simply switching numbers here. All right, it allows you to basically, if you saw a problem like this, So you had x squared over 4 is like x over, you know, I don't know, 8 or something like that. Instead of doing the whole cross multiplying stuff, this says, what this property says is that if I go ahead and I just interchange those right away, I would have that. Okay, which if you remember back to algebra stuff, this is a whole lot easier problem to work with. It's x squared divided by x is simply x. And that would become 1/2. So this is the only other one that I can see people use. Right? This one, probably not so much. This is just saying if it happens that you take the denominators of both of them and add them to the top, it doesn't change the value. All right, so probably in the matter of solving these proportions out, you're definitely going to have to use the first one because that's your cross multiply. You might run into this. I doubt anyone's going to use the reciprocal property in terms of solving these out. Okay, this is more of, like I said, you know, talking about units being in the right spot, or if you're just one of those people that don't like to see variables from the bottom. Like if I did 5 over x and it freaks you out before you solve it, you can flip it, that's fine. Some people are like that. I don't. Okay. All right. Now into the solving part. I'm going to come back to it. Okay. Let me do a couple problems for you first here. This will lead into the solving. I'm going to do some examples, then I got some time to want you guys to do them. All right, so first thing with these, this would be your simplified down. Okay, so this would be that making sure units are the same, make sure it's fully reduced, that kind of thing. And the ones I picked are ones that you'll see these units again, and this one usually people are kind of leery about. They kind of forget the whole quarts to gallon. All right, so if I was doing this one, is a gallon or a quart smaller? Like which one's smaller out of a gallon or quart? Quart, right? You guys remember how many quarts are in a gallon? 4. Good. Okay, so if I was doing this and I said, look, I want you to simplify this ratio here, first thing I would do is change the first to quarts. All right, and once you get that converted, then you can go ahead and simplify it down, which is 5. Okay, quarts cross out, 20 divided into 4. If you actually write it this way, you could have stopped actually right here and saw 4 and 4 divide each other out, so they're a little quarts. Okay. What about over here? How would I start this one? Hours to 120 minutes, so I got 25 minutes. All right, which is good because then the units kind of cross out. I'm just left with 25 over 120, but it's not fully reduced. Can someone reduce 25 over 120 for me? What goes into both of them? Should be not 5. So 5 divided. 25 divided by 5 is 5. What's 120 divided by 5? 24. 4. 8 grams. That's fully reduced because there's nothing else that goes into both. So on these two guys, I would expect the answer to be this one. And since you're doing a ratio, leave it as like 5 over 1. All right, so that you can understand that these are the same. Okay, you could have like this answer here. I could have written that way also. I'll take both of them. I don't really care which manner you put them. But if it's a ratio, don't just drop the 1. You know, just for habit of doing this part. Okay. One other thing, you guys remember feet in a mile? You don't remember that?
No.
5,280. There you go. Yeah. Right, so don't forget, if you didn't remember that, guys, just kind of write that down. Because that usually comes up with conversion stuff. 5280 feet to mile. Gallons, quart, minutes, hours, feet to inches. And if you didn't remember this one also, 16 ounces in 1 pound. Other than that, I don't think there are that many other conversions you have to deal with. It's not that you can think of. Okay. All right, now, solving part. These would be your solving for variables, right? And these would be simple, just cross multiply. I mean, it's obviously these are both proportions, variable in them. If you see a proportion, I'm saying solve for x or solve for y, cross multiply. All right? Biggest mistake though with these is when you cross multiply ones that have multiple terms in it with anything, people usually forget to distribute totals. But if I cross multiply here, I mean like those are across from each other, so I'm doing x times 12 equals these two multiplied together, which is 8 times x plus 6. Now I'm writing it that way. I understand you don't necessarily have to show that step. I'm doing that just to remind you that 8 multiplied by everything there on the bottom, okay? Or everything on the bottom multiplied by 8. However you want to think about it. So when you start this off, you got to make sure that's fully distributed there. All right. So 12 minus 8 is how much? 4. 48 divided by 4. All right, same thing goes here. I don't want to see that. Okay, don't do that. Not correct. Make sure you always remember when you're doing the cross multiplying stuff. That 6 is multiplying everything there. That 5 is multiplying everything there. 7 times 6. What? 2. Okay. Y is. Okay. That's the biggest mistake, guys. All right. And trust me, people do it now until they like stop doing math. Okay. It's not just something that happens at lower levels. It's something that happens as a constant. Especially if you do multiple proportion problems in a row. Okay, because you might do the first one right, second one right, and the third one you just get lazy with it and you forget about it. Okay? Just kind of be very mindful of that if you're doing the cross multiply. Make sure when you cross multiply, all the terms are getting multiplied together, distributed properly. Okay? Now, what you got to do, the book, geometry book. That right there. 13 is up above it. Okay, it should have been 44 games, I think they lost. Then 18, 5 over 3 over there. 23 was 7 there. 24 not being done. Should be 5 blocks is 35, 72.
I was going to do that.
What?
I was going to do that. And you were
Say
like,
5y plus 7. Like, if you say 5y plus 7, that's good.
no.
Say 5 times
I was
y
going to
plus
do
7.
exactly what you're doing over there. You were saying exactly what you're supposed to do.
That's right, because you said 5y plus 7.
Okay.
You say 5y plus 7. Not right. That wouldn't have been good. Hey. Was that 37? 37 over 5. And then 25 looks correct. Yes. What's that? It should be 3x plus 9. That 3 gets multiplied by that. 5 times 6. Here you get 5x. I mean, like, guys, watch. So you get the 5 times times x there, and then 10 times that entire thing. Gives you 10x minus 3. So
Oh yeah, I
here,
did that stuff.
7.
Oh.
All right. Move on, guys. Okay, so here's the thing: the similarity part. I'm gonna condense it down as much as I can, but the thing is, the first part you definitely have to make sure you write down. The definition of similar polygons is what you use to test whether or not they're similar. Similarity and congruency are dealt with in almost the same manner. And the fact that we're looking strictly with corresponding sides and corresponding angles. The difference between them is that when we did congruency, right, the congruent triangles and stuff, we wanted everything to be equal. Like all the pairs of sides to be congruent and all the pairs of angles to be congruent. Similarity, the only thing that has to be congruent are the pairs of angles. Okay? The other thing you want is you want to make sure the sides are in proportion. So that means you're technically just taking side lengths and putting them into ratios. So you're just making a bunch of fractions and then reducing them. And if they all reduce to the same thing, that means that the sides are in proportion. Okay? And in terms of what these do, guys, the corresponding angle part, that makes the shapes the same, like the same shape. The sides things being in proportion just makes it similar to each other. Whereas when we did congruency, like the angles gave it the same shape, and the sides being congruent made it the same exact shape, like size-wise. All right, now, everything is up there, okay? Here's how it works. If I gave you these two shapes, and like had numbers on the sides and everything, and I said, look, are those two shapes similar to each other? All the work you would do is everything that's over here. Like this would be the work part. Now, of course, if I was doing this, I would have number values for all of these here. Okay? Like I would actually have numbers on the side lengths. This is just telling you what to do. Okay, here's all your pairs of corresponding angles. That should always be the first thing you check. Because if you don't even have the corresponding angles matching up, there's no point you wasting time doing a whole bunch of ratios and stuff. All right? After you do that, you're going to take all your sides and put them into a big proportion there. All right? This thing right here, without the numbers in it, that is called the statement of proportionality. Okay? So if I ever ask you to write a statement of proportionality, I want to see without the numbers. Now, if you were actually testing it, like I said, if I gave you the problem and I said, look, are these shapes similar? I would have number values on the side. I would have a 5 there, and like a 20 there or something. And I would expect to see on the problem, like a 5 there and a 20 there. And you would move down for each one of them. Okay, this is just matching up all the corresponding sides. The actual work you would do would be plugging in the numbers and reducing the fractions. Like taking 5 over 20 and reducing it to 1 over 4. Okay? Now, if everything checked out, like if, just for example, if I'm using these numbers, right, like we'd all agree like 5 over 20 equals 1 over 4. Let's just say that every pair sides reduced down to the same thing. Like when I did CD and IJ together, they reduced to 1 over 4. Same thing on the other. Okay, if that happened, if I had all these equal the same thing, 1 over 4, just because I picked those numbers, and all the angles were congruent, then you would say this. All right, this is saying ABC is similar to GHIJ. that little squiggle. It's basically the congruency symbol minus the equal sign. Because they're not equal, they're similar, they're close. That little squiggle always means similar. Okay, now this right here, this is your similarity statement. Okay, just kind of, it's almost the exact same thing as when we did congruency statement. In this case, it's a different symbol between them. But the order of the letters still matters. Like I still want the corresponding angles to be the same. Okay? And I still want them to match up. Alright? The only difference is now I'm talking about things being in proportion as opposed to equal. Right? One other thing that I can point out from all the stuff we have. If the numbers fell in line with what I had, like the 5 and 20 that I just made up. This reduced number right here from the side, that's called the scale factor. Okay? Scale factor, guys, is simply you take two sides that you know correspond, you put them in a ratio, and you reduce them. So put everything up there. There's a statement of proportionality, you need to know how to write that. Similarity statement, you know how to write that. Scale factor, you need to be familiar with it. Okay? Alright, and that's because you're going to use the scale factors to find like side lengths and so on. It's just when you find side lengths here, you do proportions as opposed to then things equal to each other. Because the shapes obviously are not going to be equal. I can't do one side equal to another. But I can do proportions that are right here. Okay? So going through the process again, if I gave you two shapes, and I said, are these shapes similar? First thing you do, check those. Check the angle. Next thing you do, make sure you get all the sides into a big proportion, and then take the numbers and plug them in. There'll be values for each side if the question is, are they similar? And then once you get the numbers plugged into this statement of proportionality, you reduce them. If they all reduce to the same thing, the shapes are similar. If they don't reduce to the same thing, they're not similar. That's it. Okay, that entire work, this is everything you have to do for right now for like saying, are these polygons similar? Right? Okay. All right. Let's say, for example, we'll do this. There's two triangles to be easy for this. Like if I gave you these two, I said, are the triangles similar? All right. First thing you would do is check and make sure you know all the angles are congruent. Like with this one here, I've got those two are congruent, correct? Right?
Yeah.
Right. These two are congruent, right? Since I got two pairs, does that automatically make X and M congruent?
Yeah.
Yeah, there was a thing called a third angle theorem, right? Third angle theorem said, I know those are congruent as well. All right, so my first check would be, like I said, number one would be angles are congruent. Like that's what you check. Oh, that works, so it's good. Second thing would be sides in proportion. Right, so that'd be my second thing I'm checking. So now it would be a matter of you writing out like that statement of proportionality, such as XA over MN. You guys agree these two probably correspond to each other?
Yeah.
Okay. It'll be like XR over MT. Okay, so what you would technically do is this would be your statement of proportionality, but you guys probably aren't going to write this every single time. Okay, I would more expect people to go in there and go 9 over 6, 15 over 10, 12 over 8. All right, and then to make absolutely sure these are in proportion, or maybe they aren't, is to reduce every fraction. Like 9 over 6 reduces to what? Or 3 over what? 2. Right? So less. Yeah. So 15 over 10 reduces to 12 over 8, also 3 over 2?
Yeah.
That right there, seeing this, would mean that the sides are in proportion. Alright, so first step is make sure the angles are, do the work to see if they all come out to be the same ratio, which they do. Now you go, look, yes, they're similar, and then you would write a same proportionality. I mean, a similarity table. So, like XAR, triangle XAR is similar to triangle MNT. Alright, and then according to what we did down here, when we reduced them, I know that the scale factor equals 3 over 2. This is just this number we got down here when we reduced the size. Okay, so that process does not change. Right? It gets shorter when we get to like tomorrow and we deal strictly with triangles, but triangles are actually going to be a little bit easier. They could have probably done this a lot quicker if we had the seen what we talked about tomorrow. But for everything today, guys, this process needs to be the same. Check for the angles. If the angles aren't even congruent, then you just kind of move on. Go, no, they're not. Alright? Next thing is going to be this. Alright. So, if I give you two shapes, and I flat out tell you, hey, these shapes are similar, and I say I want you to find the side length, I'm telling you they're similar because I want you to set up some kind of proportion to find the side length. Okay? Because if I had that right there. Alright? This thing would be given to you, letting you know those shapes are in proportion with each other. Right? I could do something with angles also. I just don't have any variables on the angles right now. Okay, so here's the thing. This is basically what you do. You're going to be setting proportions up for every variable that's there. Okay? Meaning like, if I wanted to find W, like I would do W over whatever side corresponds to. Okay? So if I looked at W, which side over here corresponds to it? 25. So I'd have that on one side. If I wanted to find the X, I would do like X over which side corresponds to X? 10. And then Y over this one corresponds to what? 15. And then what you would do on the other side, you would just use whatever numbers that you know already match up, such as these two sides are corresponding and they both have a number on them. So I would use the 12 and 15 as some kind of ratio on each side. What you got to make sure of is you make sure whichever variable you're trying to find, the number that's on the same shape goes on like the same level. Like I have W on the top here, so the 12 is with the W, so I'm going to put that on top. Whereas with these two down here, the X and Y are on the shape that has the 15. And then you just do some basic cross multiplying. It's probably going to be pretty quick cross multiplying. Alright, so 15W equals 25 times 12. What is it? And 300 divided by 15 is? Alright, and we got 12x equals 150. 150 divided by 12. 15 times 16. $240. Alright, and then 240 divided by 12 is? What? 20. Okay. Alright, so those would be your answers. Now, what I'm telling you guys though, you see this symbol. Alright? You see this word. Now until the end of the book. and I ask you to find the side length, you must set up proportions. Similarity leads to proportions because the sides are in proportion. Do not forget that. I'm telling you now, from now until the end of the book, do not forget that. It's the biggest mistake. If we get to like chapter 10 or something, similarity comes up, I say, look, find W, and they go, oh, W equals 25. No, it's a smaller shape. You can't do the same. All right? If we get that late in the book and you do something like that,